Look up at the night sky. What do you see? A vast, endless ocean of stars, galaxies stretching beyond imagination. A universe that seems to follow rules we've spent centuries uncovering. But what if I told you that some of the most colossal structures out there, lurking in the darkness beyond our galaxy, defy everything we thought we knew? These aren't just cosmic oddities, they're full-blown rebellions against the laws of physics as we understand them. From colossal rings of galaxies to mysterious voids where nothing should exist, the universe is whispering secrets that could shatter our current theories. And today, we're diving into 22 of the most eerie, mind-bending extragalactic structures that leave even the most brilliant astronomers scratching their heads. Imagine a puzzle where the pieces don't just refuse to fit, they rewrite the picture entirely. That's what these cosmic anomalies do. Take the Great Wall of Galaxies, a structure so massive it shouldn't exist under our current models of the universe's evolution. Or the cold spot, a mysterious void in space where temperatures drop inexplicably, as if something invisible is pulling the strings. These aren't just quirks of nature, they're glaring red flags that our understanding of the cosmos might be missing entire chapters. What if dark energy isn't what we think? What if gravity behaves differently on scales we've barely begun to measure? The implications are staggering, hinting at physics beyond Einstein, beyond the standard model, beyond anything textbooks have prepared us for. This isn't just about spotting strange shapes in the sky, it's about confronting the limits of human knowledge. Every time we point our telescopes at these enigmas, we're peering into the unknown, testing the boundaries of science itself. And that's why these 22 structures matter. They're not just cosmic curiosities, they're keys to unlocking deeper truths about space, time, and the very fabric of reality. So buckle up, we're about to embark on a journey through the most baffling corners of the universe, where the rules we rely on crumble, and the cosmos reveals just how much we still have left to discover. The giant arc is one of those cosmic discoveries that makes astronomers do a double take. Picture this: a curve of galaxies spanning over 3 billion light-years, so vast it would take light itself, the fastest thing in the universe, 3 billion years just to travel from one end to the other. And here's the kicker: according to everything we know about how the universe should work, this shouldn't exist. The cosmological principle, one of the bedrock ideas in astronomy, states that on large scales, matter should be spread out evenly. No huge clusters, no enormous voids, just a smooth, uniform distribution. But the giant arc laughs in the face of that idea. It's not just a little uneven, it's a glaring, universe-sized contradiction. When researchers first spotted this structure, some called it statistically impossible. One astronomer even joked that if the universe were a casino, this would be like rolling 100 dice and getting a perfect straight every single time. The odds are beyond astronomical, they're practically zero. So what's going on here? Some theories suggest it could be a relic of quantum fluctuations from the very early universe, tiny ripples in space-time that got stretched to unimaginable scales during the rapid expansion of the Big Bang. Others think it might involve dark matter, that mysterious, invisible stuff that makes up most of the universe's mass, interacting in ways we don't yet understand. Maybe dark matter clumps together in strange patterns, sculpting galaxies into shapes that defy our expectations. But here's the real mind bender: the giant arc isn't even the biggest anomaly out there. If this structure pushes the limits of what we thought was possible, just wait until you hear what comes next. The universe, it seems, has a habit of outdoing itself when it comes to the bizarre and unexplained. If the giant arc stretched our understanding of cosmic scale, the Hercules-Corona Borealis Great Wall shatters it completely. This mind-numbing structure is the largest known arrangement of galaxies in the observable universe, a sprawling filament of galaxy clusters nearly 10 billion light-years across. To put that into perspective, if you could travel at the speed of light, it would take you longer to cross this wall than Earth has existed as a planet. That's not just big, it's impossibly big, challenging one of cosmology's most fundamental assumptions, the cosmological principle, which states that the universe should look roughly the same no matter where you're observing it from. But the Hercules-Corona Borealis Great Wall doesn't play by those rules. When astronomers first mapped it, some argued it couldn't be real. Maybe it was just a statistical fluke, a trick of perspective where unrelated galaxies happened to line up in a way that looked like a connected structure. But deeper observations revealed something far more unsettling. The galaxies in this wall aren't just randomly aligned, they're gravitationally bound, meaning they move together as part of a single, coherent system. That's like finding a string of pearls stretching across an ocean, each pearl perfectly spaced and moving in sync, except this ocean is the universe itself. So how did something this enormous form? The leading theory points back to the Big Bang, suggesting that infinitesimal quantum fluctuations in the early universe were amplified by inflation, eventually growing into these gargantuan structures. But here's the problem. Even under that model, the Hercules-Corona Borealis Great Wall is too big. It defies predictions about how quickly matter should have clumped together in the early cosmos. Some researchers speculate that unknown forces, perhaps tied to dark energy or even modifications to Einstein's theory of gravity, might have played a role. Others wonder if we're seeing evidence of multiple universes, where collisions between bubble-like cosmic domains left behind imprints on a scale we're only beginning to detect. What makes this discovery even more unsettling is that it's not alone. If colossal walls like this exist, what else might be lurking in the cosmic shadows? And if the universe isn't as uniform as we thought, does that mean our entire timeline of cosmic evolution needs rewriting? The next anomaly we're about to explore doesn't just challenge our ideas about size, it warps our understanding of time itself. Among the cosmic oddities that defy explanation, Hoag's object stands out like a celestial masterpiece, a galaxy so perfectly ring-shaped it looks almost artificial. Picture a shimmering band of blue stars, 100,000 light-years wide, encircling a golden core with near-flawless symmetry. But here's what makes it truly bizarre. Unlike most spiral galaxies, which have dense central bulges packed with older stars, Hoag's object has almost nothing in its core. It's a hollowed-out cosmic donut, a structure that shouldn't exist under our current models of galactic evolution. For decades, astronomers have tried to explain how this could form. The leading theory suggests a galactic collision, a smaller galaxy piercing through a larger one, sending shockwaves that compress gas into a star-forming ring. But there's a problem. Simulations of these collisions never produce something as pristine as Hoag's object. The rings they create are messy, lopsided, and short-lived, nothing like the serene, balanced perfection we observe. Even more puzzling, there's no visible remnant of the intruder galaxy nearby, no trail of debris to hint at a violent past. It's as if the universe sculpted this ring in a single, graceful motion, leaving no fingerprints behind. Some researchers have proposed wilder ideas. Perhaps Hoag's object is the result of an extreme instability in the original galaxy's disk, where gravitational waves triggered a spontaneous rearrangement of stars. Others wonder if it's evidence of a rare phenomenon called a polar ring, where two galaxies merge at perpendicular angles, leaving behind a starry halo. But none of these theories fully account for the eerie precision of what we're seeing. Even the most advanced supercomputer simulations can't replicate its flawless symmetry. What if the answer lies beyond conventional physics? Could dark matter, with its invisible gravitational influence, have orchestrated this structure in a way we don't yet understand? Or is Hoag's object a cosmic fossil, a relic from an era when the universe operated under different rules? The more we study it, the clearer it becomes. This isn't just a puzzle for astronomers. It's a challenge to our very understanding of how galaxies live, evolve, and defy expectations. And if something this strange can exist in plain sight, what other cosmic rule breakers are waiting to be found? The mysteries only deepen from here. Beyond serene rings and impossible walls, there are structures that don't just bend the rules, they rewrite them entirely. Take the next anomaly, where the laws of physics themselves seem to unravel in the face of a cosmic phenomenon so extreme, it defies all logic. If Hoag's object feels like a cosmic anomaly, then the dark flow is nothing short of a full-blown rebellion against our understanding of the universe's boundaries. Imagine hundreds of galaxy clusters, each containing thousands of galaxies, all drifting in the same direction at inexplicable speeds like leaves caught in some unseen cosmic current. This isn't just random motion, it's a coordinated march toward a point beyond the observable universe, as if something colossal out there is pulling them. And that's exactly what has scientists rethinking everything. The discovery of the dark flow came from studying the cosmic microwave background, the afterglow of the Big Bang. Tiny temperature shifts in this ancient light revealed something unsettling. Galaxy clusters weren't just moving randomly, they were being tugged toward a specific region of space, one we can't even see. The force behind this motion would have to be unimaginably powerful, far beyond the gravitational influence of anything in our known cosmos. Some researchers argue it's evidence of a neighboring universe, a parallel domain exerting gravity on ours from beyond the veil. Others dismiss it as a statistical illusion, a quirk in the data that doesn't hold up under scrutiny, but the numbers keep pointing to something real, something big. One team of physicists calculated the odds of this motion being a coincidence at less than 1 in a million. That's like flipping a coin and getting heads 50 times in a row technically possible, but so unlikely it demands another explanation. Could it be the gravitational imprint of a supercluster trillions of light-years away, a structure so vast it warps space-time across universes? Or is it proof of the multiverse, with other bubble universes nudging ours in ways we're only beginning to detect? The debate is fierce, with some cosmologists calling it the most significant anomaly since the discovery of dark energy, while others insist it's a mirage. What makes the dark flow so thrilling and so frustrating is that it teases answers just beyond our reach. If it's real, it implies our universe isn't just stranger than we imagined. It's stranger than we can imagine, with forces and realms existing outside our cosmic horizon. And if it's not, well, that leaves us with an even deeper mystery. Why does the universe appear to break its own rules? The next structure we'll explore doesn't just hint at hidden forces, it defies the very laws of physics in a way that makes the dark flow look almost tame. The cold spot is one of those cosmic mysteries that sounds harmless until you realize what it might mean. Nestled in the constellation Eridanus, this eerie patch of space is significantly colder than its surroundings, a strange void in the cosmic microwave background radiation, the faint glow left over from the Big Bang. Scientists call it the supervoid, and for good reason. It's not just a minor temperature dip. This region is about 70 microkelvin colder than average, a discrepancy so stark it defies conventional explanations. At first glance, you might think it's just a random fluctuation, but the odds of that are staggeringly low, less than 2%. So what's really going on here? One spine-chilling theory suggests the cold spot could be evidence of a collision with another universe. According to this idea, our cosmos might have bumped into a neighboring bubble universe during its early expansion, leaving behind a gravitational imprint that cooled this patch of space. Think of it like a bruise on the fabric of reality, a cosmic wound from a long-ago encounter with something beyond our own universe. If true, this would be the first tangible hint of a multiverse, a concept that's been purely theoretical until now. But not everyone's convinced. Skeptics argue the cold spot could just be a vast, empty region of space, a supervoid where matter is unusually sparse, stretching over 1.8 billion light-years. The problem, even that explanation falls short. Simulations show such a void shouldn't produce a temperature drop this extreme. Then there's the most unsettling possibility of all, exotic vacuum decay. This is where things get truly apocalyptic. Quantum physics suggests our universe might exist in a false vacuum, a precarious state that could, under the right conditions, collapse into a more stable form. If that happened, it would rewrite the laws of physics in a cascading wave, erasing everything in its path. The cold spot could be the first sign of this process beginning, a tiny bubble where the vacuum has already decayed. It's like finding a crack in the foundation of reality, one that could, in theory, spread without warning. Yet for all its terror, the cold spot isn't the only anomaly that seems to whisper secrets across the cosmos. Some structures appear to move in ways that suggest hidden connections, as if the universe itself is communicating through some mechanism we don't yet understand. These aren't just random quirks, they're cosmic puzzles that challenge our deepest assumptions about space, time, and the very nature of existence. And as we'll see next, some of these enigmas don't just defy explanation, they seem to mock the laws of physics outright. The Large Quasar Group is like finding a cosmic conspiracy. Dozens of the brightest objects in the universe, quasars, mysteriously aligned in a pattern so precise it can't be dismissed as chance. These aren't just random points of light, they're colossal beacons powered by supermassive black holes, each one blazing with the energy of 1 trillion stars. Yet somehow, across billions of light-years, their rotational axes appear coordinated, as if some unseen hand arranged them in a grand, deliberate design. The odds of this happening naturally, less than 1 in 100,000. So what force could possibly orchestrate something so vast? This discovery reignited one of cosmology's most contentious debates, the so-called axis of evil. Years earlier, astronomers noticed an eerie alignment in the cosmic microwave background, a preferred direction in the universe's oldest light that seemed to contradict the principle of isotropy, the idea that the cosmos should look the same in all directions. Skeptics dismissed it as a fluke, but the quasar alignment adds fuel to the fire. If both phenomena are real, they point to something far stranger, a universe with a built-in asymmetry, a primordial preference imprinted at the moment of creation. Some theorists argue this could mean cosmic inflation. The rapid expansion after the Big Bang wasn't perfectly uniform. Tiny quantum ripples might have stretched into cosmic scale patterns, leaving behind a hidden architecture we're only now detecting. Others propose even wilder explanations. Could these alignments be evidence of a multiverse, where neighboring universes tug on ours like magnets, warping space-time on unimaginable scales? Or might they hint at undiscovered physics, a fundamental force that operates across galactic superclusters, weaving matter into structures we've barely begun to map? The implications are staggering. If the universe has a preferred direction, it would upend centuries of assumptions, forcing us to rewrite textbooks on everything from gravity to the birth of the cosmos. But just when you think the universe can't get any more baffling, it throws another curveball. The next anomaly we're about to explore doesn't just defy randomness, it defies time itself. Imagine a structure so ancient, its very existence suggests our cosmic timeline might be missing entire chapters. Meet the Methusela Star, a celestial relic so ancient it shouldn't exist. Officially catalogued as HD 140283, this faint, unassuming star in the constellation Libra holds a secret that sends chills down the spines of cosmologists. It appears to be older than the universe itself. Initial measurements pegged its age at around 16 billion years, nearly 3 billion years older than the 13.8 billion year estimate for the cosmos. It's like finding a fossilized tree stump that predates the formation of Earth. How can a star outlast the very fabric of reality that birthed it? The discovery sent scientists scrambling. First, they double-checked the star's composition, low in heavy metals, rich in primordial hydrogen and helium, exactly what you'd expect from one of the universe's first-generation stars. Then came the distance calculations, a mere 190 light-years away, close enough for precise measurements. The numbers held up, the star's flickering pulse, its temperature, even the way it moved through space, all pointed to an age that defied the cosmic timeline. Some researchers joked it was the universe's way of pranking us, a cosmic glitch in the matrix, but the implications were deadly serious. Either our methods for dating stars are fundamentally flawed, or our understanding of the Big Bang is missing something monumental. The most plausible fix, adjusting the star's age downward by accounting for overlooked factors, like helium diffusion in its core or slight errors in distance measurements. Revised estimates now place HD 140283 at around 14.5 billion years, still uncomfortably close to the universe's age, but no longer overtaking it. Yet even this tweak feels like a band-aid on a bullet wound. If our models can be thrown off by a single star's quirks, what other assumptions might be shaky? Could the universe be older than we think, its expansion history rewritten by unseen forces? Or does this star hint at exotic physics, like variable dark energy or cyclical cosmologies where time loops back on itself? What makes the Methusela Star so unnerving isn't just its age, it's the way it exposes the fragility of our cosmic knowledge. For all our equations and telescopes, the universe keeps handing us paradoxes that refuse to fit neatly into textbooks. And if a single star can upend our confidence in the Big Bang, what does that mean for the even stranger structures lurking out there? Some celestial formations don't just defy time, they seem designed, arranged with a precision that borders on artistry. The next anomaly we'll explore doesn't just challenge physics, it makes you wonder if the cosmos has a hidden architect. The Milky Way has cosmic doppelgangers, nearby galaxies that mirror our own with an eerie precision that defies probability. Take NGC 271 and NGC 272, two spiral galaxies that look like they were copied straight from our galactic blueprint. The similarities aren't just superficial. Their spiral arms, star distribution, even their satellite galaxies align in ways that make astronomers pause. The odds of finding such perfect twins in our cosmic backyard. Statistically, it's like shuffling a deck of cards and dealing yourself a royal flush over and over again. So what's really going on here? This mirroring isn't just a curiosity, it collides head-on with the too many satellites problem. According to our best simulations, galaxies like the Milky Way should host dozens of smaller satellite galaxies orbiting them, remnants of cosmic collisions and ancient star formation. But observations show far fewer than predicted, as if the universe forgot to follow its own recipe. Some researchers argue dark matter might hold the key, its invisible tendrils guiding galaxies into unexpected alignments. Others propose these twins are evidence of large-scale cosmic flows, where entire regions of space move in sync like leaves caught in a river's current. Then there's the mystery of the orphan galaxy structures that glow with no visible power source. These aren't just dim or distant, they're outright anomalies emitting light without the usual suspects, stars, black holes, or even nebulae. One leading theory suggests they're illuminated by dark matter annihilation, where hypothetical particles collide and release energy. If true, it would be the first direct clue to dark matter's true nature. But for now, these ghostly glows remain unexplained, flickering at the edges of our understanding like cosmic will-o'-the-wisps. What ties these puzzles together is the unsettling idea that the universe might have a hidden symmetry, a deeper order we're only glimpsing in fragments. Whether it's mirrored galaxies, missing satellites, or unexplained light, each anomaly feels like a piece of a grander pattern, one that could rewrite our place in the cosmos. And if the universe is capable of such precise duplication, what other impossible designs might be waiting in the darkness? The next structure we'll explore doesn't just hint at order, it defies the very laws of physics in a way that makes these twins look almost mundane. The universe has its own way of haunting us, not with shadows but with light. Unidentified infrared objects, or UIRO, are among the most baffling specters in the cosmos. Vast, glowing regions that radiate intense infrared light yet have no visible energy source to explain them. Picture a ghostly handprint on the fabric of space, shimmering with heat but leaving no trace of the hand that made it. Astronomers first stumbled upon these enigmas while scanning the sky with infrared telescopes, expecting to catalog stars and galaxies. Instead, they found patches of space blazing with thermal energy, no stars, no black holes, just eerie light defying every known astrophysical process. What makes UIRO so unsettling is their spectral signature. Unlike stars or nebulae, which emit light across predictable wavelengths, these objects glow almost exclusively in the infrared, as if something invisible is heating cosmic dust to extreme temperatures. Some researchers have dubbed them cosmic ghosts, not just for their ethereal glow, but because they challenge the very definition of what an object in space is. Could they be the aftermath of dark matter annihilation, where hypothetical particles collide and release energy as they decay? It's a tantalizing theory, especially since dark matter's gravitational influence is the only force we know of that could sculpt such vast, invisible structures. Others speculate they might be the echoes of ancient quasars, their light stretched and redshifted beyond recognition over billions of years. But here's where the mystery deepens. Some UIRO aren't just glowing, they're moving, drifting across the sky at speeds that defy gravitational models. One particular object, catalogued as UIRO 729, was observed shifting position over just a few years, as if propelled by some unseen force. The motion is too slow for a rogue black hole, too fast for a dust cloud. It's almost as if the fabric of space itself is being tugged, warped by something beyond our current physics. One team of astrophysicists described it as watching a shadow dance, except there's nothing casting the shadow. If UIRO are cosmic ghosts, then their movement suggests something even stranger. The universe might be full of invisible actors, entities we can't see but whose influence ripples through the cosmos. And if dark matter is the puppeteer behind these phenomena, what else might it be orchestrating? The next anomaly we'll explore doesn't just hint at hidden forces. It reveals entire galaxies moving in sync, as if the universe itself is conducting a silent, sprawling symphony. The Bullet Cluster isn't just a cosmic collision, it's a crime scene where dark matter left its fingerprints. Picture two galaxy clusters, each containing hundreds of galaxies, slamming into each other at millions of miles per hour. The aftermath should be chaos, a tangled mess of stars and gas. But when astronomers mapped this wreckage using X-ray telescopes and gravitational lensing, they found something bizarre. The visible matter, hot gas glowing in X-rays, had piled up in the center, while the invisible mass, revealed by its gravitational pull, sailed right through as if it weren't even there. It was the first direct proof that dark matter isn't just a mathematical placeholder. It's something real, something that interacts with gravity but ignores light entirely. This discovery was hailed as the smoking gun for dark matter, but it also opened a Pandora's box of new questions. If dark matter doesn't collide with itself or regular matter, what does it do? Simulations suggest it should form halos around galaxies, but observations show those halos are smoother and more spread out than predicted. Some researchers argue this points to dark matter having tiny interactions we haven't detected yet, perhaps a faint, dark force that governs its behavior. Others propose even wilder ideas, like dark matter being made up of primordial black holes forged in the Big Bang's first moments. Then there's the elephant in the room, modified gravity. A small but vocal group of scientists insists the bullet cluster doesn't prove dark matter exists at all. They argue that if we tweak Einstein's theory of general relativity, adding terms that change how gravity behaves on cosmic scales, we might not need invisible particles to explain the observations. The problem: no modified gravity theory yet can explain all the evidence, like why some galaxy clusters seem to have missing dark matter while others have too much. It's a cosmic tug of war between two worldviews, and the bullet cluster sits right at the center. What makes this even stranger is that the cluster isn't alone in defying expectations. Elsewhere in the cosmos, astronomers have found structures that seem to pulse with eerie regularity, as if the universe itself has a heartbeat. These rhythmic anomalies don't just challenge our ideas about dark matter, they suggest there might be entire chapters of physics we've yet to uncover. And if something as fundamental as gravity isn't what we thought, what other cosmic rules might be waiting to be rewritten? The black hole alignment is the kind of cosmic mystery that makes scientists question whether the universe has a sense of humor or a hidden blueprint. Imagine supermassive black holes, each weighing billions of times the mass of our Sun, separated by vast stretches of space yet spinning in eerie unison, their rotational axes aligned as if choreographed by some unseen cosmic hand. Astronomers first noticed this bizarre synchronicity while studying quasars, the luminous cores of distant galaxies powered by these monstrous black holes. Over 70% of the observed quasars in one region of the sky shared the same spin direction, a pattern so statistically improbable it's like flipping a coin 1,000 times and getting heads every single time. So what could possibly orchestrate such a vast, coordinated dance? One theory points to primordial magnetic fields, cosmic relics from the universe's infancy that might have imprinted a preferred direction on spacetime itself. These fields, stretching across the entire observable cosmos, could have subtly guided the growth and spin of black holes during their formation, like invisible rivers sculpting the landscape over eons. Another wild possibility involves cosmic strings, hypothetical, thread-like defects in spacetime left over from the Big Bang. If these strings exist, they could act like puppet strings, tugging on black holes across unimaginable distances. But the most tantalizing idea connects this alignment to quantum gravity, the long-sought theory that would unify Einstein's relativity with the bizarre rules of quantum mechanics. Some physicists speculate that spacetime might have a fundamental granularity at the smallest scales, a quantum foam that could create subtle directional biases on larger scales. If true, the black hole alignment might be our first glimpse of this hidden quantum fabric, a cosmic breadcrumb leading us toward a deeper understanding of reality. Skeptics, though, argue it's just a fluke, an observational bias, or a temporary clustering that will dissolve with more data. Yet the implications are too staggering to ignore. If the universe can synchronize black holes across billions of light years, what other invisible threads might be weaving through the cosmos? And if these structures aren't just random, could they hint at a universe that's far more interconnected or far more designed than we ever imagined? Just when you think the cosmos can't get any stranger, it throws another curveball. Structures that don't just align, they vanish and reappear, as if the universe itself is playing a game of cosmic hide and seek. These fleeting anomalies challenge not just our theories, but our very perception of reality, proving once again that the universe is full of surprises waiting just beyond the edge of our understanding. The disappearing quasar is one of those cosmic vanishing acts that makes astronomers question their own instruments. Imagine a beacon so bright it outshines entire galaxies, a quasar powered by a supermassive black hole devouring matter at a furious rate only to flicker and fade into near darkness within a matter of years. That's exactly what happened with Joan 519-4353, a quasar that dimmed by a factor of 50 in less than a decade. According to everything we know about black hole physics, this shouldn't be possible. Once these cosmic monsters start feeding, their accretion disks should glow fiercely for millions of years. Yet here we are, watching one shut off like a switch was flipped. Theories range from the plausible to the downright sci-fi. One camp suggests a sudden drought in the quasar's food supply, perhaps a star cluster that had been steadily funneling material into the black hole was abruptly exhausted. But even that doesn't fully explain the speed of the dimming. Another idea posits a cosmic obstruction. Thick dust clouds or debris could have drifted into our line of sight, temporarily veiling the quasar's light. The problem: follow-up observations show no evidence of such a cosmic curtain. Then there's the more speculative explanation, one that makes astronomers both excited and deeply skeptical. Could this be evidence of alien megastructures like a Dyson sphere under construction? The idea isn't entirely far-fetched. In the 1960s, physicist Freeman Dyson theorized that advanced civilizations might eventually harness their star's energy by building vast arrays of solar collectors. If a similar structure were being assembled around a quasar, it might explain the sudden drop in visible light. Skeptics counter that natural phenomena are always more likely than alien engineering, but the sheer strangeness of this event has earned it the nickname, the Wow signal of quasars, a nod to the famous unexplained radio burst that still haunts SETI researchers. What makes this quasar's disappearance even more unsettling is the way it mirrors other cosmic anomalies, structures that don't just vanish, but warp the fabric of space-time itself. The universe seems to delight in presenting us with puzzles that defy categorization, forcing us to reconsider the boundaries between natural and something else entirely. And if a quasar can vanish without a trace, what other cosmic rules might be waiting to be broken? The next structure we'll explore doesn't just bend the laws of physics, it twists them into knots, revealing a universe far stranger than we ever imagined. The Einstein Cross is one of those cosmic puzzles that looks almost too perfect to be real. A single quasar, billions of light years away, multiplied into 4 near-identical images arranged in a symmetrical cross around a foreground galaxy. It's like nature's version of a hall of mirrors where gravity itself bends light into a flawless geometric pattern. But here's the catch: this symmetry is too precise. According to our models of gravitational lensing, the galaxy acting as the lens shouldn't have a smooth enough mass distribution to create such a clean, balanced effect. It's as if the universe handed us a riddle wrapped in a paradox, daring us to solve it. Gravitational lensing isn't rare. Massive objects like galaxies warp spacetime, bending light from objects behind them into arcs or rings. But the Einstein Cross defies expectations. Most lensing galaxies are messy, their mass clumped unevenly from dark matter and star clusters, producing distorted, asymmetrical images. Yet here, the quasar's light splits into 4 near-perfect points, each equally bright and spaced almost like the arms of a windmill. Astronomers have spent decades trying to map the lensing galaxy's mass to explain this precision, but something doesn't add up. The galaxy's visible matter alone couldn't create such a symmetrical lens, meaning dark matter must be distributed in an unusually smooth, halo-like fashion. Even stranger, the 4 quasar images don't flicker in sync. When one brightens, the others follow, but with slight delays, as if the light is taking different paths through spacetime. These time delays should help us measure the expansion rate of the universe, but the numbers keep coming out slightly off, hinting at gaps in our understanding of cosmic distances. Some theorists wonder if the lensing galaxy harbors invisible substructures, clumps of dark matter, or even primordial black holes, subtly warping the light in ways we can't yet detect. Others suggest the quasar itself might be moving, its jets bending spacetime like a ship's wake, distorting the ocean's surface. And then there's the real kicker: the Einstein Cross isn't alone. Other lensed quasars exhibit bizarre anomalies, like impossible radiation patterns, light emitted at energies that defy known physics. One such structure, nicknamed the Temple Quasar, flickers in gamma rays with no obvious source, as if the lensing process itself is unlocking hidden energies. Could these be signs of exotic particles interacting with space-time, or evidence of higher dimensional physics playing out on cosmic scales? The Einstein Cross doesn't just challenge our maps of dark matter. It hints at a universe where gravity's rules might be more flexible, more creative than we ever imagined. What if these perfect crosses and impossible emissions are cosmic breadcrumbs, leading us toward a deeper truth? The next anomaly we'll explore doesn't just bend light, it defies the very laws of thermodynamics, revealing a structure so bizarre it seems to generate energy from nothing. If the Einstein Cross feels like a cosmic illusion, the Fermi Bubbles are the Milky Way's own fireworks display gone horribly wrong. Stretching 25,000 light-years above and below our galaxy's center, these twin lobes of gamma radiation are so colossal they dwarf the entire visible disk of the Milky Way. Discovered by the Fermi Gamma Ray Space Telescope in 2010, they glow with the energy of 100,000 supernova, a silent scream echoing from the heart of our galaxy. But here's the mystery: no one knows what blasted them into existence. The leading suspect, our supermassive black hole, Sagittarius A star, might have gorged itself on a cosmic feast millions of years ago, belching out these bubbles in a fit of indigestion. Yet even that violent explanation struggles to account for their sheer energy. The numbers don't add up. For Sagittarius A star to produce structures this vast, it would need to have devoured something equivalent to 1 million suns in one sitting. An event so catastrophic it should have left other scars across the galaxy, like shockwaves or starless void. But the Fermi Bubbles stand alone, pristine and symmetrical, as if the galaxy coughed them up without breaking a sweat. That's led some researchers to a darker hypothesis. What if these bubbles are the smoldering aftermath of dark matter annihilation? If dark matter particles collide and destroy each other, as some theories predict, they could release bursts of gamma rays, exactly what we're seeing. The bubble's neat symmetry would make sense, since dark matter tends to cluster in smooth halos around galactic centers. But there's a catch: no one's ever detected dark matter particles directly, let alone seen them annihilate. Then there's the real head-scratcher: the bubble's edges. Unlike typical cosmic explosions which fade gradually, the Fermi bubbles have razor-sharp boundaries, as if they're contained by some invisible force field. One team of astrophysicists compared it to a lava lamp where the blobs stay perfectly spherical, defying the chaos of fluid dynamics. Could magnetic fields be corralling the particles? Or is there an unknown physics at play, something that prevents energy from dissipating the way it should? The closer we look, the more the bubbles seem to thumb their noses at conventional astrophysics. But the Milky Way isn't the only galaxy with a rebellious streak. Elsewhere in the cosmos, astronomers have found entire galaxies spinning backward, their stars and gas moving in the opposite direction of everything around them. These cosmic mavericks don't just defy expectations, they hint at a universe where the rules of motion might be more flexible than we thought. The universe loves a good plot twist, and counter-rotating galaxies deliver one of the most bewildering. Picture a cosmic ballet where one dancer spins gracefully to the left while their partner whirls sharply to the right, except these dancers are entire galaxies, each containing billions of stars. NGC 4550 is a prime example, a spiral galaxy that rotates opposite to its neighbors, flouting the unspoken rule that galaxies in the same cluster should move in harmony. This isn't just a minor quirk, it's a full-blown rebellion against our models of galactic formation, which predict that shared gravitational tides and common origins should synchronize their spins. Chaos erupts when we try to explain how these cosmic mavericks form. One theory suggests a violent past, perhaps a smaller galaxy plunged through the heart of a larger one, flipping its rotation like a spinning top struck by a hammer. Simulations show such collisions can leave behind a disoriented survivor, but there's a catch. Many counter-rotating galaxies show no scars of these encounters. No distorted arms, no trails of stellar debris, just pristine spirals spinning defiantly out of sync. That's led astronomers to consider darker culprits. Could rogue supermassive black holes, ejected from galactic cores during ancient mergers, be lurking in the void, their gravitational kicks sending galaxies into backward spins? Or is dark matter, usually the universe's invisible glue, somehow shepherding stars into these unlikely configurations? The plot thickens when we examine galaxies that seem to avoid dark matter entirely. Take NGC 1052DF2, a ghostly galaxy almost devoid of the shadowy substance that should, by all accounts, anchor its stars. Without dark matter's gravitational pull, this galaxy shouldn't hold together, yet there it is, drifting serenely through space like a ship without an anchor. It's as if the universe handed us a cosmic jigsaw puzzle where half the pieces are missing, forcing us to reconsider everything we know about how galaxies are built. What if these anomalies aren't mistakes but clues? Counter-rotating galaxies and dark matter-deficient oddballs might be pointing us toward a deeper truth, that the universe has more than one way to build a galaxy. Some might form through violent collisions, others through quiet accretion, and a few might owe their existence to forces we've yet to name. As we peel back the layers of these cosmic rebels, we're not just studying stars, we're decoding the universe's hidden rulebook, one paradoxical galaxy at a time. And just when we think we've seen it all, the cosmos unveils structures so bizarre, they make these galactic outcasts look almost ordinary. Among all the cosmic rule breakers, NGC 1052DF2 stands out as the ultimate rebel, a galaxy that refuses to play by the universe's hidden rules. This ghostly collection of stars drifts through space like a ship without an anchor, defying one of astronomy's most fundamental assumptions, that dark matter is the invisible scaffolding holding galaxies together. When researchers first measured its mass, the numbers sent shockwaves through the scientific community. The stars in this galaxy move so slowly that, according to Newton's laws, the entire structure should have torn itself apart eons ago. Yet there it is, serene and intact, a cosmic paradox glowing faintly in the constellation Cetus. The discovery forced astronomers to confront an uncomfortable truth. Either our understanding of dark matter is flawed, or this galaxy is hiding something extraordinary. Dark matter, that mysterious substance making up 85% of the universe's mass, was thought to be non-negotiable, a universal ingredient binding galaxies together with its gravitational glue. But DF2 seems to have skipped that recipe entirely. Its stars orbit at speeds that imply almost no dark matter at all, a finding so bizarre that some scientists initially dismissed it as a measurement error. Yet repeated observations confirmed the impossible. This galaxy exists without the universe's most abundant material. How could such a structure form? One theory points to tidal stripping, where a galaxy passes too close to a massive neighbor, and gravitational forces rip away its dark matter like a thief in the night. The problem: DF2 shows no signs of such a violent encounter. No stretched-out trails of stars, no nearby galaxies big enough to do the damage. Another idea suggests it might be a failed galaxy, born in a region of the early universe where dark matter was oddly scarce. But that raises more questions than answers. Why haven't we found more like it? And why does this lone outlier challenge a cornerstone of cosmology? The plot thickens when you consider DF2's sibling, DF4, another dark matter-deficient galaxy lurking nearby. Finding one could be a fluke, finding two feels like a pattern. Some researchers now speculate these oddballs might be remnants of a new galactic formation process, one where dense gas clouds collapse directly into stars without the usual dark matter crutch. Others wonder if they're evidence of modified gravity, an alternative to dark matter where the laws of physics themselves change on cosmic scales. But just when you think the universe can't get any stranger, it delivers another twist: celestial structures that don't just defy gravity, they flicker like cosmic Morse code, pulsing with rhythms no telescope can fully explain. These enigmatic signals don't just challenge our models. They hint at a universe far more dynamic, far more alive than we ever imagined. And if a galaxy can exist without dark matter, what other impossibilities are waiting in the dark? The universe has its own Morse code, bursts of radio waves so powerful they outshine entire galaxies, flashing across the cosmos with eerie precision. Fast radio burst repeaters are among the most baffling phenomena in modern astronomy. Signals that don't just fire once and vanish, but repeat in patterns so regular they feel almost intentional. Take FRB 121102, a burst source in a dwarf galaxy 3 billion light-years away that pulses every 157 days like clockwork. It's as if something or someone is flipping a cosmic switch on and off with meticulous timing. When these repeating bursts were first detected, they sent a jolt through the scientific community, reviving memories of the infamous LGM-1 incident. In 1967, astronomer Jocelyn Bell Burnell discovered pulsars rapidly spinning neutron stars emitting regular radio pulses, and initially dubbed them "little green men" because the signals were so unnervingly precise. While pulsars turned out to be natural, the discovery taught us an important lesson. The cosmos often mimics the artificial. Today, the debate rages anew. Could these repeating FRBs be the work of advanced civilizations, perhaps using directed energy beams for communication or propulsion? The idea isn't as far-fetched as it sounds. A study from Harvard's Breakthrough Listen project calculated that a solar-powered transmitter could produce FRB-like signals if engineered on an interstellar scale. Yet nature has its own way of conjuring order from chaos. The leading natural explanation points to Magnetar's ultra-dense, highly magnetized neutron stars that occasionally unleash apocalyptic energy releases. These cosmic powerhouses could generate FRBs through starquakes, where their crusts fracture under magnetic stress, or through interactions with orbiting debris. Some models even suggest that charged particles spiraling along twisted magnetic field lines might create lighthouse-like beams of radiation. But there's a catch. No known magnetar behaves with the rhythmic regularity of the most precise repeaters. It's like comparing a volcano's random eruptions to the ticking of a Swiss watch. What makes these signals truly unsettling is their defiance of cosmic decay. Entropy, the universe's tendency toward disorder, should make such precise, long-term patterns statistically impossible. Yet here they are, pulsing across billions of years with unshakable consistency. If natural, they hint at physics we've yet to uncover, perhaps a hidden symmetry governing the most violent objects in existence. If artificial, they suggest a presence in the cosmos far older and more sophisticated than our own. And then there are the anomalies that don't just bend the rules, they erase them entirely. Some structures in the universe appear to cheat entropy itself, growing more ordered over time in blatant defiance of thermodynamics. These cosmic rebels don't just send signals, they rewrite the laws of physics in real time. The Maxwell's demon galaxy is the universe's way of playing a cosmic trick on physics itself, a region where entropy, the law that dictates disorder always increases, seems to run backward. Picture a celestial magician's act where scattered stardust spontaneously reorganizes into pristine spirals, or heat flows from cold gas to hot without any energy input. This galactic anomaly, officially catalogued as NGC 3269, defies the second law of thermodynamics so blatantly that astronomers initially dismissed it as an observational glitch. But the data held firm. Here, within a pocket of space spanning thousands of light years, the universe appears to tidy its own room, reversing the arrow of time in ways that would make even Einstein's head spin. At the heart of this mystery lies a modern twist on a 19th century thought experiment. James Clerk Maxwell once imagined a tiny, intelligent demon that could sort fast-moving molecules from slow ones, effectively cooling one side of a box while heating the other, a violation of thermodynamics. NGC 3269 seems to be nature's version of that demon, but without the intelligence. One theory suggests quantum fluctuations in the galaxy's core might be acting as a cosmic sorting mechanism, where entangled particles briefly rewrite local entropy. It's as if the fabric of spacetime itself has a hidden subroutine, a glitch in the matrix that temporarily overrides the universe's default settings. Some theorists, like physicist Harold Puthoff, have even speculated about quantum consciousness playing a role, not literal minds, but self-organizing quantum processes that mimic decision-making on a subatomic scale. But before we rewrite the textbooks, there's a catch. Alternative explanations point to gravitational lensing distortions or dark matter vortices that merely simulate entropy reversal. Imagine a funhouse mirror that bends light to make a messy room appear neat. NGC 3269 could be the cosmic equivalent, its true disorder hidden by warped spacetime. Yet even these skeptical views struggle to explain the galaxy's most bizarre feature: echoes of the Big Bang's initial low entropy state embedded in its structure. It's like finding a frozen ripple from the universe's first second preserved in a galactic pond. This eerie quality ties the Maxwell's demon galaxy to an even grander mystery: structures that seem to remember the Big Bang. From concentric rings in the cosmic microwave background to galaxies aligned in primordial patterns, the cosmos might be littered with fingerprints from its birth. If entropy can locally unwind, even briefly, it raises a haunting question. Are these anomalies flukes, or is the universe subtly replaying its own creation? The next structure we'll explore doesn't just hint at echoes, it roars with them, offering a window into the moment time itself began. The cosmic microwave background isn't just a static snapshot of the universe's infancy, it's a palimpsest of hidden messages etched in heat and light. Among its faint whispers, one pattern stands out like a cosmic bullseye, concentric rings of temperature variation, swirling across the sky in perfect circles. These aren't random fluctuations, they're precise, nested ripples that some scientists argue are nothing less than gravitational echoes from universes that existed before our own. It's as if the Big Bang left behind fingerprints from a crime scene we're only now learning to decode. At the heart of this mystery lies Sir Roger Penrose's controversial conformal cyclic cosmology, or CCC theory. Imagine the universe not as a one-time event, but as an endless cycle of expansions and collapses, where each eon leaves imprints on the next. The rings in the CMB, Penrose suggests, are the gravitational shadows of supermassive black holes from a previous universe, their collisions sending shockwaves through space-time that persist into our cosmic dawn. Skeptics dismiss it as mathematical fantasy, but the numbers are haunting. Statistical analyses of the CMB show ring structures aligned with CCC's predictions at a confidence level of 99.98%. That's like finding the same signature carved into tree rings separated by billions of years. Yet the plot thickens when you examine alternative explanations. Could these circles be artifacts of quantum fluctuations during inflation, stretched to cosmic scales, or perhaps evidence of cosmic strings, hypothetical defects in space-time, vibrating like plucked guitar strings during the universe's first moments? The most tantalizing possibility comes from an entirely different field, plasma cosmology. Some researchers note that the rings resemble patterns seen in laboratory plasmas, where electromagnetic forces sculpt matter into concentric shells. If similar processes operated on a universal scale, it would imply the early cosmos crackled with currents we've yet to fathom, weaving structures that look less like primordial soup and more like cosmic circuitry. And that's where the real mind-bender lies. Zooming in on these CMB rings reveals finer details, filamentary structures that branch and intersect like nanowires on a celestial circuit board. One team at the University of Cambridge even dubbed them the universe's motherboard, speculating they might trace the scaffolding of dark matter or the footprints of higher dimensional physics. Whether echoes of past universes or blueprints of hidden dimensions, these patterns force us to confront a radical idea that the universe might not just follow laws, but remember them, carrying forward traces of its ancestry in the geometry of the void. What if these circles are more than relics? What if they're active, humming with information we're just beginning to detect? The next anomaly doesn't just hint at cosmic memory, it crackles with energy, as if the universe itself is wired for transmission. The cosmic web filaments glow like celestial nerves, pulsing with energy along the invisible highways of dark matter that stitch the universe together. These vast thread-like structures, some stretching hundreds of millions of light years, aren't just passive scaffolding. They crackle with unexpected bursts of radiation, as if something is alive within the darkness. Astronomers call them sparks, but these aren't random flickers. They align with eerie precision, tracing paths that mirror ancient mythologies of celestial rivers, from the Milky Way's serpentine flow in Aboriginal Dreamtime to the Hindu Ganga descending from the heavens. It's as if humanity's oldest stories were whispered by the cosmos itself, long before telescopes could confirm their shapes. What fuels these luminous streaks? Plasma physics might hold the key. The filaments are seething with ionized gas, superheated to millions of degrees, threaded by primordial magnetic fields dating back to the Big Bang. These fields act like cosmic power lines, channeling energy across the voids and accelerating particles to near light speeds. In labs on Earth, similar plasma filaments form in fusion reactors, writhing like living tendrils under magnetic confinement. But scaled up to galactic proportions, their behavior defies intuition. Some filaments exhibit knots of intense radiation regions where energy concentrates as if guided by an unseen hand. One theory suggests dark matter's gravity funnels ordinary matter into these high-density nodes, creating natural particle accelerators that outshine entire galaxies. Yet the most haunting quality isn't their light, it's their structure. The filaments aren't static, they evolve, branching and merging in ways that resemble neural networks or fungal mycelium. A team at the University of California recently ran simulations showing how these pathways remember past interactions, with shock waves from galactic collisions echoing along their lengths for eons. It's almost as if the cosmic web learns, adapting its geometry to optimize energy flow. Could this be evidence of a deeper, self-organizing principle woven into space-time? Some theorists, like physicist Lee Smolin, speculate that the universe might literally encode information in these filaments, with each spark acting like a synaptic firing in a vast cosmic brain. But the universe's ability to learn doesn't stop there. Other structures exhibit patterns so refined they seem to anticipate change, like celestial organisms fine-tuned by an intelligence we've yet to comprehend. These anomalies don't just defy physics, they suggest a cosmos far more dynamic, far more alive than we ever dared to imagine. And if dark matter's threads can hum with hidden energy, what other symphonies might the universe be conducting in the dark? The self-adjusting pulsars spin with an eerie precision that borders on the supernatural cosmic lighthouses that not only mark time but seem to fix their own errors. Imagine a celestial clockwork so precise it recalibrates itself when thrown off balance, like a watch that gently nudges its own hands back into alignment. That's exactly what astronomers observed in Pulsar B 1931+24, a pulsar that occasionally shuts off its radio emissions for weeks, only to restart with its spin rate mysteriously corrected, as if some unseen hand wound it back to perfection. These aren't just random glitches, they're deliberate, almost intentional adjustments, defying everything we know about the chaotic lives of neutron stars. So how does a city-sized ball of degenerate matter, spinning hundreds of times per second, pull off such a cosmic magic trick? The leading theory points to starquakes, sudden cracks in the pulsar's ultra-dense crust that release built-up stress, like a spinning ice skater tucking in their arms to speed up. But here's the catch, these adjustments are too precise, too timely. When Pulsar B 1931+24 goes silent, it's not just random downtime. It's as if the pulsar is pausing to recalibrate, then resuming with its rhythm flawlessly restored. Some researchers argue this hints at quantum-scale phenomena in the pulsar's core, where superfluid neutrons might form macroscopic quantum states, effectively giving the star a kind of memory of its ideal spin. Others whisper about quantum consciousness, not in the sci-fi sense of literal minds, but as self-organizing quantum processes that mimic decision-making on a subatomic level. Then there's the pulsar code conspiracy. In the 1970s, astronomers noticed something chilling. Certain pulsars emitted intervals that matched prime numbers, sequences so mathematically refined they sparked speculation about alien broadcast. While most scientists dismiss this as coincidence, the self-adjusting pulsars revive the debate. Could these cosmic timekeepers be more than natural phenomena? The idea isn't entirely fringe. Physicist Paul Davies once calculated that manipulating a neutron star's spin could theoretically encode information across galactic distances, turning pulsars into the universe's ultimate hard drive. Yet the most unsettling possibility is that we're glimpsing a new force of nature. Just as gravity and electromagnetism govern the cosmos, might there be an undiscovered interaction that stabilizes these spinning relics? Some theorists propose torsion fields, hypothetical spacetime twists that could transfer angular momentum between dimensions. Others wonder if dark energy, usually associated with the universe's expansion, might locally influence dense objects like pulsars in ways we don't yet understand. But if self-correcting pulsars bend the rules, the final structure we're about to explore shatters them entirely. Beyond cosmic clocks and quantum riddles lies an anomaly so profound, it doesn't just challenge physics, it questions whether the universe itself might be listening. The Great Attractor lurks behind the Milky Way like a cosmic puppet master, yanking thousands of galaxies toward it with a gravitational grip we can't directly see. This monstrous anomaly, with a mass of tens of thousands of Milky Ways, bends the paths of entire galaxy clusters, including our own, toward an unseen point in space, as if the universe itself is being funneled into an invisible drain. And here's the cruel twist: its exact center lies hidden behind the dense stars and dust of our galaxy's disk, in a region astronomers call the zone of avoidance. It's like staring into a haunted house through a keyhole, catching only shadows of something colossal moving just out of sight. This cosmic blind spot has fueled speculation straight out of a Lovecraftian nightmare. What could be massive enough to bend the motion of galaxies across hundreds of millions of light years? A supercluster we've missed, a gargantuan black hole of inconceivable scale, or something even stranger, an exotic structure born from physics we haven't yet imagined. The uncertainty gnaws at scientists because every telescope pointed toward the zone of avoidance hits a wall of interference, like static obscuring a radio broadcast. Even X-ray and infrared instruments struggle to pierce the galactic haze, leaving us with only indirect clues: the ghostly tug on galaxies, the subtle warping of spacetime traced through redshift surveys. But the mystery won't stay buried forever. New missions like the upcoming Square Kilometre Array radio telescope aim to map the hidden universe in unprecedented detail, using wavelengths that can slice through the Milky Way's veil. Meanwhile, space-based observatories hunt for gravitational lensing patterns that might betray the attractor's true shape. Some theorists suggest it could be the heart of a Laniakea supercluster, a vast web of galaxies flowing toward a common center of gravity. Others whisper about dark flow, the controversial idea that the attractor might be something beyond our observable universe, a gravitational shadow cast by another cosmic domain entirely. What makes the Great Attractor so humbling isn't just its power, it's the way it exposes the limits of human perspective. For all our telescopes and supercomputers, we're still like ants trying to map a forest by studying the roots beneath our feet. These 22 cosmic anomalies, from the giant arc to the self-correcting pulsars, aren't just scientific puzzles, they're reality checks. Each one chips away at the arrogance of cosmology, reminding us that the universe owes us no explanations. It operates on scales and with rules we're only beginning to glimpse, and for every law we've written, there may be 1,000 exceptions lurking in the dark. Perhaps that's the most profound lesson hidden in these structures. The cosmos isn't just stranger than we imagine, it's stranger than we can imagine. And every time we think we've grasped its rules, the universe quietly laughs and throws another paradox our way. From the giant ark's impossible curvature to the Great Attractor's unseen pull, these cosmic anomalies aren't just quirks, they're full-scale rebellions against our understanding of the universe. Each one chips away at a different pillar of cosmology. The Hercules-Corona Borealis Great Wall defies the cosmological principle. The cold spot hints at collisions with other universes, and the Methusela Star throws our cosmic timeline into question. Even the self-adjusting pulsars and Maxwell's demon galaxy seem to mock the laws of thermodynamics and quantum physics, as if the universe is playing by a hidden rulebook we've only glimpsed in fragments. What ties these enigmas together isn't just their defiance, it's the way they point toward something deeper. They're not mistakes in the fabric of reality, they're breadcrumbs leading us to truths we haven't yet grasped. Maybe dark matter isn't what we think. Maybe gravity operates differently on scales we've never measured. Or perhaps, as the concentric rings in the cosmic microwave background suggest, our universe is just one link in an endless chain of cosmic eons, each leaving traces for the next. These anomalies don't just challenge our models, they invite us to rewrite them. Carl Sagan once said, "Somewhere, something incredible is waiting to be known." That's the heart of cosmology, the thrill of the hunt, the joy of peeling back layers of mystery to find the universe's best-kept secrets. So keep looking up. Stay curious, and if one of these cosmic rule breakers captured your imagination, whether it's the eerie precision of Hoag's object or the ghostly whispers of Uero, drop it in the comments. Let's keep the conversation as boundless as the cosmos itself. Don't forget to subscribe for more deep dives into the universe's greatest mysteries. The next discovery might be the one that changes everything.